From the Microsoft Technology Center in Minneapolis, Minnesota, this is Tech Connection Live. Brought to you by Woomo from Component One. Download your free trial at woomo.com. Up next, Intro to SignalR by Kevin Griffin, Microsoft MVP and Technical Evangelist at Component One.
So normally I show this really fancy, awesome photo of me. So as Larry said, I'm a technical evangelist for Component One. I'm Microsoft MVP, all that good stuff, and I really like steak. And so I'm on Twitter at @1kevgriff, and my email address is keving@component1.com. If at any point after you leave today, if you have any questions, please feel free to send me email or talk to me on Twitter. Usually pretty responsive. Before I begin, I want to talk about just one of our products that I'm going to show later in one of the SignalR demos called Woomo. How many web developers do I have in the room? Okay, fair number. So Woomo is our suite of HTML5, CSS3, jQuery UI extensions. So if anyone's out there that's doing web development that needs to do data visualization stuff, so say you need charting solution, you need a bar chart, line chart, pie chart, whatever, or you need a grid, gauges, but you don't want to use something robust like Silverlight or Flash to do that. You want to use an iPad because that's what your customers or clients have. Woomo is a great solution for that because we render everything in the browser. So it's all HTML5 in the very end. We have over 40 controls in our suite. I don't expect you to understand that whole list, but just know we have a little bit of everything that you need. So when you have a chance, you should have got a Woomo thing in your packets. Go to woomo.com. And if you have any questions about Woomo along the way, feel free to shoot me an email.
Is rendering Canvas or SVG?
SVG, so it will work in IE6. Which, for how many people is that a benefit? Works in IE. So my agenda for the next 75 minutes, we're going to talk about what SignalR is. But first, we're going to start with a little bit of a history lesson. How do we build up to where we are today? We're going to talk about where SignalR kind of fits into this picture, and then we're just going to do a whole bunch of demos. First, how many web developers do I have in the room again? So who's been around the web since the internet was AOL? All right, so I was like 8 at the time, but I've been around. It's all right. The web really hasn't changed fundamentally since it's begun. How does the web work? Someone sits down at their computer, that thing, and they open up AOL. It says, you got mail. They open up the little web browser inside of AOL, and they say, go to webcrawler.com or AstaVista or Dogpile. What are some of the old websites? And they hit enter. So the computer goes to AOL, this magic thing called the cloud, the internet, and it says, I need webcrawler.com. So it sends a request out, and it goes to this magical thing called a server via a request. The server says, oh, yeah, I know what you're looking for. Let me go fetch it off a disk, and I'm going to send it back to you as a response. So, and that's pretty much how everything on the web has worked. So the client gets it back, it parses the web page, says, okay, now I need underconstruction.gif. So sends a new request for underconstruction.gif. Server says, okay, I got that on disk. Goes and gets it and sends a response. Back and forth, request, response, request, response. Now we have Web 2.0. So how many people were just kind of jumping in when Web 2.0 was taken off? Okay, never mind. So same thing. I have a client machine that talks to this magical thing called the internet connecting to a server. So a request comes in and a response goes out. The only difference is we have rounded corners and gradients. So request comes in, response goes out. We're also introducing some new terminology. So we're taking better advantage of this request-response cycle to make our websites a little bit more responsive. So the the big buzzword that really came out of this was Ajax. So how many people consider themselves Ajax developers? And if you use an Ajax toolkit, you can put your hand down. So who's using the Ajax toolkit? Okay. After this, you're going to go back and say, we're going to rip all that out and put this in. So jQuery became kind of the library that we use to do all this stuff. Even though jQuery is not the only solution, there's plenty of other good solutions that do what jQuery does, and even does some things better than jQuery. But because Microsoft, we blessed jQuery, everyone started using it, it kind of blew up. And most recently, we're introducing terms such as real-time applications and single-page applications. Who's heard these buzzwords going around? Okay. The one I want to focus on is real-time applications. So how many people would say they use a real-time web application day to day? Off and on. And real-time's in quotes for a reason. So when I say real-time, it's I can bring a browser up, load the web page, and I don't need to do anything to the web page for it to be responsive. So how many Gmail users do I have? Okay, you all use a real-time web application. You're sitting there on your laptop, you have Gmail open, I go over there and I send you an email. It goes up into the cloud, goes around, and within, it doesn't happen immediately, but within a couple minutes, it pops up on your screen. So that's relatively real time. I don't have to sit there and push the refresh button. How many Woot users do I have? Who loves Woot? Don't you hate hitting that refresh button? Don't you wish they would just push the new information to you? So real time is, I can have an application set up and it's going to keep me up to date with what's going on. If I'm building a dashboard for a client, should I have to hit refresh every time I want fresh information? Probably not. It'd be great if it would update those numbers for me as it could. That leads us into, let me do a demo first. How many people have one of these? If you do, pull it out. So most presenters will ask you to please put away your cell phone. I'm asking you to pull yours out. And if you have messaging, which most people do, please send a text message to the phone number on the screen here. And don't worry, I'm only using your phone number for good. I'm giving it to my boss back there, and he's going to call you every day until you buy licenses. So don't worry, I'm not doing anything with phone numbers. So as you guys do that, I'll do it too.
I see you have a rounded corner.
I do.
Just one. That's Web 3.0.
It is. You have to get fancy with the rounded
That's
corners.
right.
If you do just 4 rounded corners, that's Web 2.0. 1 or 2 rounded corners is 3.0. Oh, and if you have a laptop out, you can go to signalrio.kevgriffin.com, and you can watch the updates coming in real time along with what's up here on the screen. And not only that, I have an iPad up here. Let me wait for it to actually respond. Here we go. So I don't know if y'all can see this, but as messages come in, they should be popping up on the iPad at the same time. So you're not limited to just what's happening in the browser or to a single PC device. Cell phones are kind of iffy. So like this Windows phone doesn't do anything. But that's more of a limitation in SignalR right now. So I want to talk about what the architecture behind this, because it's really cool, and it's kind of a real-world way of using SignalR. So let's start at the very beginning. You pull out your phone, and you send a text message to 757-941-GRIFF. And type in your message, you hit send. Well, that message is going up into the cloud. I'm using a service called Twilio. How many people are familiar with Twilio? One or two. Okay, if you're not familiar with Twilio, you should be familiar with Twilio now. Twilio is a service that provides voice and SMS capabilities to applications. So if you've ever wanted to build some sort of phone relay system for clients to call into, or you wanted to send notifications to customers, say we wanted to notify you that something really bad happened, so you need to go take care of it now. Twilio is a system that does that for you, and it's all REST-based. When you send an SMS to that number, Twilio sends me a notification to a special URL I gave it on this domain. When I receive that message, I use SignalR to notify anyone that's currently connected to this web page. So that's why when you send a message, it goes here, it goes to my iPad, it goes to anyone that's currently connected. So SignalR doesn't care. How many people send messages? So just randomly, how long did it take from the moment you press send to make it here? A couple of seconds. I mean, if you're AT&T, it's all right to wait. But like my Verizon Awesome phone, I hit send, it's right there. So it's all right, guys. It's funny. So we see the cycle happening. And this leads me into what I see coming down the future, redefining how we look at the net. And that's what I'm coining as Web 3.0. So here in the next year or two, when people are saying, well, I'm a Web 3.0 developer, you heard it here first. I invented that term. Just like Al Gore invented the internet and AOL implemented it. I'm going to have a machine. I'm still going to have this thing called the internet. I'm still going to have a server. The only difference is I'm not going to have this request response cycle. Instead, I'm going to just open this pipe between my client and my server. And this is really powerful stuff because now, instead of the client always having to request something from the server and the server always having to send a response, I've now created this channel where my client can send information to the server, but my server can also send information back to my client whenever it feels like. So if I have Gmail open and I get a new email, the server can just tell the client. Gmail doesn't, on the browser, doesn't have to keep going back asking, is there a new email? Is there a new email? Is there a new email? Over and over again. So how do we do this now, today? Let's say SignalR is not even in the equation. Well, there's a couple different approaches. I'm covering three. One that I've done consistently, and a couple that are not as well known. First is interval polling. Interval polling is the concept of using the request response cycle on an interval basis. So if my client wants to check for email, let's say every 10 seconds, it sends a request to the server saying, is there new email? And the server says no, sends a response. Well, then 10 seconds later, sends another request. Says no, response. So that's not a bad approach. The problem is that there's a lot of bandwidth and overhead required to do something like that. Because I'm sending a request every 10 seconds. Some things maybe every second, or some every 5 minutes. It doesn't matter. But I have to have all this bandwidth to just get nothing back. Next is long polling. And long polling is a similar idea, except I open a connection to the server and just leave it open. Then once the server has some relevant data it can send back to me, it uses the existing pipe to return that data. So I have a little bit lower bandwidth because I open one connection, and it usually stays up for a maximum of 2 minutes. But if anytime during that 2 minutes the server has data, it can use that existing pipe. I can drastically cut down on my bandwidth. And then finally is the holy grail. This is what you're going to be doing in the next 1 to 5 years, is WebSockets. And that's, who's done old school socket programming before? So you open a connection, you open a listener on the server, and you connect to it from a client, and you have a single pipe that you can connect to or talk over between the both of them. WebSockets is the same way, except you have a web client and you have a web server. So there's a couple problems with WebSockets right now, especially for Microsoft developers. This is where SignalR kind of pokes its head in, because SignalR decided, instead of you having to implement one of these different approaches, it figured out that it can implement those approaches for you and then pick the best way to transport data based off of the browser and the server technology that you're using. So let's say you're running IE6. Well, IE6 will never have support for WebSockets, ever. But it can do long polling. I mean, that's been around since AOL days, technically. So SignalR will implement long polling. But if I'm using the latest Chrome bits and I'm talking to IIS8, WebSockets is a much more efficient way to send data and receive it. So it's going to implement WebSockets. But you only have to write one code base. So the next demo I do, when we actually build something with SignalR, keep in mind, SignalR is doing all this transport negotiation for me behind the scenes. I don't care. One last note on WebSockets. This really is the future once we catch up to it. So client-wise, we're not really worried. Unless you're supporting IE, then you should worry. Right now, only IE10 supports WebSockets natively, but Firefox and Chrome have supported it for quite a while. If you want the full matrix of what browsers support what, I have the website up here at W3. SignalR can use WebSockets if you're using IIS8. That's because IIS7 doesn't have support for it on the server. Also, if you're a Node.js user, you can implement WebSockets with Node.js, and there's a SignalR connector that can work that way too. So you're not completely out of the loop. Even though the demos I'm doing today are all based around ASP.NET, don't limit your thinking to just ASP.NET. There are several other server and client implementations that can use SignalR. For server, of course, ASP.NET. There's the new OWN standard. They have hooks for that. You can also self-host SignalR. So if you already have an existing server setup that I don't know, runs as a Windows service up in the cloud, whatever, you can just inject SignalR, and it worked the same way as though if it was hosted in ASP.NET. On the client, everything I'm going to show is going to be JavaScript, but if you're using Silverlight, Windows Phone, iOS, WinRT, Micro Framework, the sky's the limit. You have client options. So if you build something on ASP.NET and you build it right now to talk with JavaScript, but later you want to build a Windows Phone app, well, you write the Windows Phone hooks that talk to ASP.NET. You don't have to rewrite your server code. You just reuse what you already have. You're just building a new client. This has been since version 4. They just released 0.5 yesterday. So when I go through all my demos now, keep in mind, they totally broke the API. So I was in rush mode to figure out what they broke, so I didn't show you any bad demos. I've already pre-built a skeleton here for our app. There we go. So up here on the screen, I have a text box and a submission button. And what I like to do is I like to type something into the box, hit submit, have it send it up to the server. The server will receive it and then rebroadcast it out to anyone that's connected to the website and be published inside this incoming messages box. Simple enough. Right now it doesn't do anything because I haven't wired that stuff up. But if we go into my app, this is just a basic MVC 3 site. If you're doing web forms, that's perfectly okay. SignalR doesn't care what your rendering technology is. If you go into NuGet, I've already done this in advance because I wasn't sure what my internet connection would be. But if you search for SignalR, it's going to return a couple packages, but there's really one in particular that you're going to be looking for. And that's the package that just says SignalR. Not SignalR.hosting, not SignalR.whatever. This guy right here. When you install that, it's going to install a couple dependencies. For example, SignalR.js, SignalR.server, SignalR.hosting.asp.net. This is all the stuff that it needs to run in an ASP.NET instance. But if you scroll down, you can see there's also the standard .NET client. There's some stuff for unit testing, WP7, self-hosting, whatnot. So there's a lot of stuff in NuGet that you can go download and play with now. With that installed, the first thing I'm going to do is write the server-side functionality. And SignalR works around a concept called hubs. And think of a hub as a central connection point for all your clients. So if you're a Windows Phone user, you know your people hub is where you go for all your people contacts and stuff. I don't know if the naming works in the exact same way, but that's what they gave us. A hub is just a really bare bones basic class that inherits from one of the SignalR libraries. In particular, not SingleR, SignalR.hubs.hub. And that tells SignalR that this is something that it can talk to. And what we're going to do is just create a public method on it. We'll call this broadcast message. And it takes a string parameter. And what this method's purpose is when I'm over on the website, so if I bring it back up, when I hit the submit button, I want to send a message up to this method, because this method can take it and it can go do whatever it needs to with it. In particular, I wanted to send the message to all the connected clients. SignalR gives us a dynamic object here called clients. If I zoom in, so what's nice about clients is it's dynamic. What's bad about it is you don't have IntelliSense, so if that's really important to you, you're just going to have to learn how to code for real. Well, what's nice about it be dynamic is I can tell clients, I want you to execute a client-side method for me. In this case, I want to create one called writeMessage. And what writeMessage will do is when I'm back over here on the client page, it will actually put it here inside of the incoming messages box. And it's just going to pass a message in. So if I save this, and this line of code, SignalR will take it and it will do all the work for you. How many people would say I'm lying if I said I'm done with C# code right now? You can be truthful. I'm done with C# code for now. So I don't have to write anymore. I'm done. There's no, go execute query, whatever. Now I can go straight into the home index. This is the page we were just looking at. Up here at the top, I have my input, my button, and where all the incoming messages are going to go. And I'm going to have an unordered list in here. So up here at the very top, usually I write this by hand, but I forgot to take it out, no big deal, is what I call the SignalR secret sauce. So I already added the SignalR JavaScript file over here in my layout page, or master page for web forms folks. So I don't have to worry about including it there. But here, I need to tell SignalR about the different classes that I have implemented on the server. If I go and run this as is, I actually go to that link, so SignalR/hubs. It's going to spit out some dynamically generated JavaScript. And you can ignore pretty much all this, but the one thing I really like to show off is this guy. So this, if you pay attention, you'll see it's extending the SignalR object, which is extended off of jQuery, but it's creating a chat object, and this chat object implements a broadcast message method that takes one parameter, or two parameters, but the callback doesn't count. One parameter, our message. If you recall, if we go back over to our code, I have chat hub with a method on it called broadcast message that takes one parameter, message. So SignalR went through, reflected over anything that implements hub, and created this JavaScript object. Because this is now being injected into my client app, I can do stuff with it. So I can talk to that server-side method. So down here I have my ready script. So if I go and say, I'm just going to cache the object because it's a pain in the butt to write this. Connection.chathub. The $, because I'm extending off of jQuery. jQuery uses $. SignalR creates a connection object. This is where all your different hubs are going to be attached to. And then the chat hub object, which is this guy. With this, say, well, I really need to wire up this write message method that I'm calling. If I call it now, it's going to silently fail because it doesn't exist on the client. So why don't I go write it? So write message is just a function that takes one parameter. And when I get a message sent to this, I'm going to go into the messages, and I'm going to append a new list item. We'll do this the quick and dirty way. So that's one line of code. Takes whatever message comes in and puts it inside a list item and shoves it into the messages unordered list. Simple jQuery stuff. Next, I want to wire up the button. So I have some text, which is inside the text input box. Get the value of it. And then I want to go to the chat hub, and I want to call broadcast message. Well, because I already know that it's exposing broadcast message, I can just say broadcast message and pass in the text. And then now that everything's wired up, I need to tell SignalR to negotiate the connection. So we'll go connection.hub.start. And this is a very important line because this is the line that will go connect to the server, and it will say, I'm running on IE6, whatever, and I want to try connecting with WebSockets. And the communication is going to go back and forth, and it's going to figure out, okay, you're on IE6, you can't use WebSockets. Well, can I use server frame? No, you can't use server frame. Well, can I use long polling? That's my last resort. Yeah, you can do long polling. That's fine. Let's use long polling for all of our communication. If someone on Chrome connects and they say, well, I want to talk WebSockets, if SignalR is configured to use WebSockets, they'll say, sure, we'll talk WebSockets. I'm talking to this guy using long polling because he hasn't updated his browser in 20 years. So we're both going to talk to you, and it's going to work exactly the same. I'm going to go in here, put a breakpoint on write message. I'm going to rerun this, because this is the point where I've either been perfect or it's going to fail miserably. I'm going to say hello world. I'm going to hit submit. I hit my breakpoint. If I IntelliSense in message, you'll see it says hello world. So now I'm going to call into clients. I'm going to say clients write message, or run the method write message. If I run that, so now I have hello world in my box. So that's cool, but how does it work with multiple clients? So let me snap two clients next to each other. I'll go in here and remove this breakpoint so it's fancy. And I hit submit, pops up in both boxes. So let's recap. I wrote 1, 2, 3, 4 lines of C# to implement a server-side functionality. Over here, I wrote 15 or so lines of code. I could have condensed this down more if I wanted to make it smaller, but all intents and purposes, I didn't write that much JavaScript. But now I have an application where my client can talk to my server, and my server can talk to my client. Now, if you were trying to do this with traditional jQuery Ajax, which is really a really good technology, you would have to write a lot more code. You would have to come in here and you'd have to write, .get JSON, do I has messages, and it's going to go up and it's going to say, no, you has no messages, and it comes back. This is much cleaner syntax, easier to implement, I think easier to understand than someone that's learning jQuery Ajax from the very beginning. Let's see, so sending messages to server, completion, and failures. So you're all here, so that automatically tells me you write the world's best code. But I'm really worried about your coworkers because they don't write as good as code as you do. So we might want to test for their failures and their successes. So let's say when I make this broadcast message call, I want to know that that actually succeeded. Well, there's two ways you can do it. I'm going to show you the common way and the way you should do it. And that's using jQuery built-in promise that says when broadcast message is done and successful, I want you to call this callback. And what we'll do is we'll say, we'll just throw up an alert, success. So what should happen if I go in here, if I type a message, hello world, when I hit submit, within a second, it should pop up a box that says success. So success, cool, we did good. But this isn't your code we're talking about. We're talking about your coworker's code. What happens when they do something so stupid that you need to test for their failures? What happens when broadcast message fails in some way? Failures in this case are anything that would return a not a 200 HTTP result. So if you're throwing exceptions in code, if there's a server error or something, that's more of a failure. A success would be something that would return a valid 200, or not 200, yeah, 200. So if you have server-side logic that you have your own success and failure codes, you're not going to use fail to test for those. You would need to test for success and then parse it yourself. We're talking about cases where I do this. Where somewhere inside of my server code I throw an exception. So if I run this as is, if I say test and submit, Visual Studio will pop up saying I threw an exception. I'll continue to let it fall through. It hits my fail promise on the client. It says you fail. Fine, I can go do something to remedy that. What's nice about promises is you can chain them. So if I say fail, I can also have done down the line. If I back up, one nice thing that fail does that you couldn't get from jQuery Ajax, as far as SignalR is concerned. How many people have used jQuery Ajax calls? So if you're doing it on ASP.NET and something throws an exception, what does your error stack look like in the result? It's not just the, here's the error that was thrown. It's the HTML for the yellow screen of death, right? Or whatever your custom 404 or 500 page is. And it's not very useful unless you want to take all that data and parse through to find the one little bit of information that's useful to you, what the exception was. So in my fail promise, if I pass in the error, let's say I just say error. Run it again. If I go test one more time, hit submit. So it passes my exception through. That exception message actually gets passed through into the error. So I can do something with that. I can say, here's the reason it failed, blah. Okay, we'll close those. I'll close those. So let's clean this up. So there's one question that no one's asked. I'm waiting for someone to ask it. Yes, sir.
Can I set up multiple listeners? So say I have some real-time meters sending messages up, and I want different clients to pull those messages back, different desktops. So say I have 2 or 3 different meters that I connect up, and I'm sending real-time data up to them, but I want different workstations to connect to different.
Yes.
All the same code.
Are you talking about, because I'm trying to allude to the question I want someone to ask. Are you talking about if I have multiple clients up, I can send selective messages to certain clients and not broadcast to all of them?
Yes.
Okay, that's an excellent question. I'm so glad you asked that. So here's what the problem is for the rest of you that weren't paying attention to that exchange. I have a single object here called clients. When I call a method on clients, it sends that message to all my connected clients. Well, how many people have a scenario where you want to always send every message to every client? Okay. What's a better use case? Let's say I have an application that has some sort of notification system built into it. I have Bob and Sally. They're both connected, and they're using the product. Something happens. I need to notify Bob about it. It's top secret, confidential, whatever. Sally is not cool enough to know about it. Not saying anything bad about Sally. She just doesn't have the pay rate. Bob needs to know about it, though. But if I broadcast that message to everyone, there's a good chance that Sally might see something. So how do I send it to just Bob? Very cool. Let me answer that question for you. Clients is a very unique object, being dynamic. Think about it as a list of clients. So think of it as an array. Every connection has a context, and most importantly, they have a connection ID that uniquely identifies this connection from other connections. If you want to get fancy about it, it's a GUID. Actually, if you look at the factory that creates the connection IDs, it says return GUID.new or whatever. Because of this connection ID, I can pass that into clients, and SignalR will send the right message trigger to only this client. So what should happen? I'm going to load 2 instances here to test. So if I say test and I hit submit, test should only go to me as the sender. Sally over here shouldn't see it. Hit submit, only I got it. So cool. There's an easier way to write this. This is a lot of code to write. It's actually easier to just type caller. So if you want to send a message to just the person that sent in the request, you use caller. Caller works the exact same way as clients does. So we could do something like this. So if I say, caller, write message. Thank you for your message. And if I hit F5, let's load up my other page here. I have to refresh because it was code update. If I say test now or teased, so I get the personalized thank you for your message, and everyone gets teased. There's also a feature in here called grouping. So I just showed you how to send to one particular person, but let's say you might have a group of particular people you want to send to. Administration, sales, marketing, whatever. Wouldn't it be nice if I could have groups? And with groups, I could add a person, so a connection ID, to a group called sales. And then later, I could say, I want all the clients who are in the sales group to get the message, we made money. Cha-ching. And after the fact, I remove them from the group. So if I run this one more time, I'll refresh this guy. If I say test and submit. So for the short period of time, we have this call in here. I get added to the sales group. I get a message because I'm in the sales group that we made money. I send everyone the initial message, and then I remove myself from the group because I didn't want to stick around it in any way. One cool thing you can do is implement iConnected. Well, let's say when someone connects, I want to add them to a group. So we'll check their permissions. Are they an admin? Whatever. Then we'll add them to the group. Admin. I can also, when they disconnect, I don't have to do this, it's not important, but I can remove them from the admin group. Or I could tell other admins, write message. Someone logged off. So just an idea. The reconnect is the same as connect, so if you already have the browser up and running, it maintains a connection for you, but as you know with internet stuff happens. So if it ever loses the connection, SignalR will automatically try to reestablish it, and when that happens, it calls reconnect. Now I want to show you a little bit more of a fancy demo. Let's run F5 here. I call this demo the final showdown, and you'll see why. There we go. Okay, and what we're doing here is we have multiple clients that can connect here, and when they vote, their vote is reflected across all the connected clients. I come in here and I'll create a whole bunch, and I'll pull them out. You know, this guy likes pie, so when he likes pie, everyone likes pie. If I create one more, this guy likes cake. So it's always 50-50. But people can go in, they can change their vote. So I really wanted my vote to be pie. And it can go back and forth. It only records one vote. And this is running Woomo in the background. So I send Woomo all the vote information. It renders the fancy pie chart for me. Let's show you what's happening behind the scenes. I have a hub. It implements SignalR.hubs. It's a couple of public methods on it. Most important one's vote. So when I hit one of those buttons, vote cake, vote pie, something gets sent to this method. The string is whatever I'm voting for. So it's going to be pie or it's going to be cake. I go in, I cache the connection ID. Because the connection ID is unique for every connection, I can track who votes for what. I have two dictionaries, a vote tracker, so I can check that connection ID ABC voted for pie, XYZ voted for cake. Then I have another dictionary that counts the votes, so there are 10 votes for cake, 10 votes for pie. And then down here at the end, I create a Woomo, a list of Woomo pie chart series items, which are simple. They contain a string for a label, a Boolean for a legend entry, and then the actual data, which is an integer. So I create a list of those for all the different things that are being voted for. So mostly pie and cake. And then I take this whole complex object and I call the update votes method on all my clients. I pass that complex object in. Yes?
Is there anything special about validation when using SignalR? I mean, I imagine you'd want to throw an exception if it's not cake or pie in that example.
You mean if I come in here, if I bring up a console because I'm an elite hacker,
Yeah.
and I say console, and if I say connection.vohub.vote bacon, and I hit enter, I add bacon to my vote list. We need to make bacon trend in the final showdown. That's a good question. Right now, you could use jQuery validation stuff. I mean, the libraries are already built for that. SignalR doesn't do a lot of that automatically for you, at least not yet. So it's 0.5 release. They're lucky they have cloud support now. So they're working slowly on different things.
So you'd want to write the validation on the client side and then do a similar validation on the server, throw an exception, make sure the client can handle that exception.
Yeah, exactly. I mean, it's not a, you can use this and we will solve all your problems. And you should never trust input from a client, ever, unless you're writing a demo application. So yeah, if I was writing this for more production use, I definitely would have something in here that would make sure that, vote for is one of the 2 values that I accept. But then if you want to do something with it, you have to either throw an exception, which all you get is really string data with that until they make that a little bit more of a robust system. Or you have to say, let's say we do, if, vote for, I'm going off script, so I don't have any warranty against this code. If vote for is not equal to pi, call all the clients and say, or caller, say, notify error, send an error object back to them, and then return, abandon the call. So if you're doing anything with EF object validation and whatnot, you could do your validation here, and if you need to escape, you can just return out of the method. You don't do any of that other stuff. But if you call notify error, SignalR can sit over here and go, look, I got an error message from the server. You did something really bad, and this is what the server told me. So over here, I had typed bacon, and I could do that because wrong demo. Because here I just take a string. But what was really cool is I'm passing back a complex object. And where I was going is over here. If I look at the actual code, I cache the connection because I don't want to type that every time. I wire up the update votes call, or method, that takes a series list. So this is just an array of objects. I can take that object and I can pass it directly into Woomo. So Woomo, using jQuery UI syntax, I update the option for series list. I pass that complex object directly in. Woomo knows how to take that data and do the animation to the new values. I'm done. I don't have to do anything else. SignalR is handling the JSON serialization for me. It uses JSON.NET, not that crappy ASP.NET JSON stuff. So when you send in data, it serializes it to JSON, comes back over here to the client. Client takes it and deserializes it into an actual JSON object. So, and we can actually do something with it. This is just setting up the pie chart for the first time. And then my 2 buttons, which are hub.vote, pass in pi, and then hub.voteCake. Down here on the start method, I'm using a promise. So we had used promises on the broadcast message. But here, I wanted to know when the negotiation was done between the client and the server. So I could call the hub to preload all my data. Over here I have preload, counts up all the votes, and updates the votes on for the caller. Does anyone know why I have to do this versus doing something like this? And I'll run this so you see what the error looks like.
Because it has to be in the DOM before you can affect it?
You're close. Let me show you the error first. That might spark. So here's the error. Connection must be started before data can be sent. Call start before send. But I did call start before send. That's because start is asynchronous. So I call start, it goes off into its own thread, whatever, and negotiates that connection. My code can keep executing as we go down the line. So as soon as I come in here and I call preload, it's going to try to go talk to the server across a pipe that does not exist. So any initialization stuff I want to do has to be done inside of some sort of callback. So I can use the done promise for that. I can say hub.preload, it goes and gets all my data. And that's why if I take a new tab, it loads. So I'll go hide. Now if I open a new one, it goes and gets the data on that. So if anyone comes to the game late, they get all the current information. Jabber. This is the demo that the SignalR team has been working on. So if you come in here, it's a glorified IRC channel in the web. And come in here, there's David Fowler, he's one of the developers. Oop. I believe there are active people in the room, so if we give it a second, someone might say hi. But this is all, I won't show that. This is running up in Azure. It's actually running across 16 instances. It's using Service Bus to communicate messages between all the different nodes. The use case that we run into is if I put something up in Azure that uses SignalR. How many people develop anything on Azure now? Or just kind of understand the fundamentals of Azure? The problem that we run into, let's say I have a couple nodes in here. So these are all web roles. They're all talking to a single client or a couple clients down here. So I have a client, they connect to my web page, and this is Azure, or the Azure load balancer. You connect to Azure. Your connection goes into the load balancer, and the load balancer decides which one of those 4 instances of the web role that you're going to connect to. Let's say in this case, he goes to instance 2. SignalR just established a one-to-one connection between that client and that server. So only that instance knows how to send data back to that particular client. If I have a worker role off somewhere else in Azure doing work and it needs to send a notification, it can't just say notify, connection ID XYZ, because it doesn't know about connection XYZ. So what Azure does is it puts it up in Service Bus, all these nodes talk to it, and when they see something that they can work with. So I understand that connection ID. I can send that message for them. This is really cool if I'm using, if I'm in WebSockets, I'm usually one-to-one to a server. But if I'm long polling and I had established that first connection to this particular instance, well, long polling only exists as long as that request is open. So that request opens, and let's say it times out after 2 minutes. That connection goes away. SignalR automatically establishes a new connection. Goes up into the load balancer. Load balancer says, okay, now you're going over here. So I'm now on a different node. So you can't even have logic where this guy is doing all the work for any clients that are connected to him. Because now I don't have a client connected to that guy anymore. He's now over here. But he still has the same connection ID. And because all these guys are talking to Service Bus, they can share connection IDs across all the different nodes. And with the 0.5 release that came out last week, they made that process really easy. We can go into the wiki and they show you the configuration objects, configuration items for configuring Service Bus in a SignalR application. They did all the work for you. You don't have to do it. Did anyone say hi? Hi. Someone else came in here. So, all the code that I worked with today, the updated for 0.5, is up on GitHub. This is my short link to it, c1.ms Griff SignalR. You can also go get SignalR on GitHub now, github.com/SignalR. And of course, if you have any questions, just feel free to send me a message on Twitter or via email. And thank you all for coming today.
Tech Connection Live. Brought to you by Woomo from Component One. Download your free trial at woomo.com.
Take your HTML5 applications to the next level with Woomo. Woomo is a complete kit of over 40 UI widgets. Enjoy rich, interactive charts, data grids, menus, and more. With Woomo, your web applications will perform faster, run smoother, and be more engaging than ever before. Built with HTML5, jQuery, CSS3, and SVG, Woomo widgets make your applications ready for today's web. Easily develop a consistent look and feel across your entire application with one of our professionally designed themes, or put together your own with ThemeRoller. Woomo, it's everything you need to build a better web. Go to woomo.com and download your free trial of Woomo.